Good day, folks. My name is Ricardo Gutierrez, and I am a Cloud Network Security Architect. And I would like to welcome you to the How to Connect to AWS in a Quick and Inexpensive Way Part 2. Today, I will walk you through the side-to-side ipsec VPN using GRE tunnels architecture. So your boss comes to you and tells you, hey, I just had a meeting with the finance team and they just spun up a new environment in AWS and they needed connectivity yesterday. And they need a solution that can provide high throughput, that is scalable and secure. Oh, and by the way, we need it by the end of the week. In this video, I will give you a walkthrough of an architecture that provides a solution to build connectivity to AWS within hours if you have Terraform code. If you do not, then it'll probably take you a day or two to build everything manually. In this video, I will give you an architectural walkthrough of the site-to-site ipsec VPN using GRE tunnels to the transit gateway. And one of the architectural benefits is that this provides end-to-end dynamic routing from on-premises to AWS, so you don't have to build any static routes. This provides a high available architecture because we have dual firewalls in your data center. In this case, this example is demonstrating that we have two firewalls in HA mode, in active and passive mode. So if you're not familiar with how Palo Alto works, this means that one of the firewalls is actively forwarding and inspecting packets while the other one is on standby. So if the active firewall fails, then the other one, or the passive one, takes over. In AWS, we will have two firewalls as well. These are standalone firewalls, so that means that both firewalls are actively routing packets. The other feature that makes it highly available is that we have dual ipsec tunnels from on-premises to AWS, to the firewalls in AWS. If you notice, the firewalls in AWS are in two different AZs as well. That means availability zones. And availability zone, if you're not familiar, means it's a data center in the region. For instance, if you have firewalls in the US East 1 region, which is Virginia, in that region, AWS has 6 data centers. So in this diagram, I have built a firewall in the AZ1A and the other firewall in the AZ1B. So this provides high availability, redundancy, and separate physical fault domains, which makes it very trustworthy. In the data center, we have two ISP connections. So what you want to do is build your ipsec tunnels from these ISPs to the firewalls. This solution is a scalable solution, and the reason being is that in AWS you can have multiple firewalls, so you can scale up horizontally. That means you can spin up another firewall, let's say in AZC, and another firewall in AZD. So now you have 4 firewalls connected to your data center. And of course, you would have to build your ipsec tunnels to those new firewalls. So this provides a very scalable solution. This solution also makes the connection very secure, or the traffic very secure, because you are encrypting traffic from on-prem to your AWS firewall. So that means that if you're running FTP between your data center and AWS, that traffic will be encrypted. And if you use HTTPS in your AWS applications, then you'll have the tunnel encryption plus the application encryption, which makes it even more secure. The throughput you can expect from this solution is 2 times 5.6 gigabits. And what does that mean? That means that each VM700 can handle up to 5.6 gigabits per ipsec tunnel. And since you have 2 ipsec tunnels to the data center, that means you have 2 5.6 gigabit connections to AWS. So after going over all the architectural benefits, I will now go over the traffic flow. How does this pattern work? Well, you have here on the left side, you have your on-prem network. So let's say you have a server that wants to talk to a database in AWS. So the packet sources from the data center, it sends a packet to the active firewall right here. Then the active firewall has a BGP route to AWS. In this case, we have 2 active ipsec connections. And on this firewall, we have ECMP enabled. So that allows us to load balance the packets or the sessions to the destination. So this will allow us to leverage our 2 ipsec tunnels. So there will be active if you will, and you will send traffic and use those 2 ipsec tunnels. So once the packet hits the ipsec tunnels, the traffic will hit the internet gateway in AWS, and then the packet will either hit the firewall in AZA or in AZB, depending on ECMP, which one it decides to send the packet to. Then after the packet hits the firewall, this firewall is running BGP as well and ECMP. So on this firewall we have one GRE tunnel which provides up to 20 gigabits of throughput, but since the firewall provides only 5.6 gigabits of throughput using ipsec tunnel, that'll be your bottleneck right there, but still 5.6 is very good. And this can be used as a temporary connection or a backup connection if you have a direct connect gateway. So now once the packet hits the GRE tunnel, this packet will be sent to the transit gateway peer connect, and the peer connect is the attachment that handles all BGP. That's where the BGP session lives, if you will. Then once the packet hits this attachment, then the packet will be sent to whatever VPC the server belongs to. So let's say I have a database server behind here. The packet will be sent to this transit gateway attachment, and then it'll hit the device in this VPC. And in the next video, I will demonstrate and give you a demo of what the route tables look like on the firewalls and what it looks like in AWS. Well, thank you very much for watching, and look in the description below so you can get a chance to see the discounts and other free content. And please join the club. And if you need custom training, look in the description below. There will be a URL that will send you to a form that you can fill out and request your training. Some of it might be free, some of it might be paid, but feel free to fill out the form. And please like and share and subscribe and join the club. Thank you and have a good day.